Hello, my name is Meagan Craddock, and this is my Exam 52A presentation on quantitative genetics. This is a list of the relevant terms and formulas to be referred back to as needed while going through the presentation. Just for reference, the pixies want ear lengths closer to the pixie on the left that are more human-like compared to the ones on the right that are longer and would be very noticeable. I surveyed the entire population of pixies, around 5,000 individuals, and found that they had an average ear length of 10 centimeters with a standard deviation of 3 centimeters. A histogram of the original population can be seen on the screen and has a normal distribution. The broad sense and realized heritability of ear length is 0.85 and 0.67 respectively. Because the goal is to decrease the length of pixie ears to blend in better with human-length ears, the 10% of pixies with the smallest ear lengths were selected to breed, around 500 individuals. This is called the trunication point and is equal to 6.154. This number can be found by taking the mean of the original population and adding it to the product of the standardized selection point and the standard deviation. All pixies with ear lengths below this number were selected to breed. Please note that because this trait is being decreased, Z and I are negative. If the trait was being increased, the numbers would be positive. Next, we find the selection differential, which is the difference between the selected population's mean and the original population's mean. To determine the selection differential, multiply the selection intensity and standard deviation. The selection differential is equal to negative 5.365. Then the selection differential is used to determine the mean of the selected population by adding the mean of the original population and the selection differential, which is 4.735. Response to selection is used to determine how much gain is made when the selected parents are mated. We can calculate response to selection by multiplying the realized heritability by the selection differential. Response to selection is equal to negative 3.5276. The last thing we want to find is the mean of the offspring population by adding the response to selection and the mean of the original population. The mean of the offspring population is 6.4724. Here I have added a bell curve to both populations. The mean of the offspring population is skewed more to the left at 6.4 centimeters. The average ear length in humans is around 6.3 centimeters, so the offspring average ear length is perfect for the pixies to blend in with humans. This is a histogram of the offspring population. It also follows a normal distribution. The reason why my response to selection would decrease in later rounds is because when doing the original experiment, the proportion selected was about 10% out of 5,000, the original population, so the selected proportion was about 500 pixies. If we did the experiment again with those 500, assuming there were 500 offspring, only 50 pixies would be chosen. These pixies would have a lot less diversity between them in terms of ear length. As the diversity decreases, the response to selection decreases because there is not as much variation in ear length for the offspring to have.